Okay. Okay. Another few minutes. Another few.
Can we start, sir?
Yeah, I think just 1 minute.
Okay, sir.
Hello, sir. Good evening, sir.
Good evening, Saktivel, Dr. Saktivel.
Good evening, sir. Good evening, sir.
I think okay. 1 minute. Yes, you can. Okay, previous we can start, sir.
Okay, sir. Good evening, participants. CSI Chennai, ACM Chennai, IEEE Madras cordially invite you to a webinar on machine learning for 5G and beyond opportunities and challenges by Ms. Annapurna Pradhan, Ph.D. Research Scholar, Electrical Engineering Department, National Institute of Technology, Rourkela, Odisha. This is part of our Tuesday series of webinars. Machine learning will be a necessary part of any 5G network since it's more complicated than previous generation networks. It operates at higher frequencies, introduces more complex antenna cell configurations, and employs more sophisticated connectivity mechanisms like multi-antenna technologies such as beamforming. AI and ML offer several ways to boost network performance. ML can help optimize overall network management and monitoring, drive efficient resource consumption, and enable customized network layering to give owners more control over their network usage. The speaker will present a comprehensive overview of emerging studies on machine learning and deep learning based physical and medium access control layer enhancements in 5G. To be specific, a brief idea regarding the 5G service classes, that is enhanced mobile broadband, ultra reliable low latency communication, and massive machine type communications, and the scope of ML and DL in facilitating the quality of service requirements will be focused. In addition to this, the challenges and possible solutions in implementing ML and DL in 5G will be presented. The open research areas will be presented for motivating further developments in enabling 5G and beyond wireless communication. Ms. Annapurna is currently a Ph.D. research scholar under the supervision of Dr. Sushmita Das, Dean, NIT Rourkela, preceded by over 10 years of experience in academia as an assistant professor. She is currently working on ultra-reliable, low latency communication using MLDL techniques and trying to work on industrial automation use cases. Apart from that, she is a public speaker at various platforms, chief mentor of Machine Learning Club at NITR, and well versed with her volunteering activities worldwide. She is also the ambassador for AI Exponential Thinker for India. Over to Ms. Annapurna. Thank you.
Thank you very much, sir, for this nice introduction. Sir, I'm really excited to present this topic to our listeners. So, the topic for me to speak on this is today is the machine learning for 5G and beyond technology. This itself is having so much the potential to machine learning or AI. There are so many queries in the mind of the listeners that what is machine learning, why AI is there, then what is 5G and beyond technologies. So all this overview I will try to cover in this my stipulated time period. So 5G and beyond, that means 5G is a generation of cellular communication, and what the machine learning will offer in enhancing the ability of 5G technology and the wireless technology in general. So every work needs a motivation. So why machine learning in wireless communication? So machine learning creates motivates us just because of there are so many interesting areas like advances in machine learning in other fields. Then intelligent systems. What is able? Those are able to produce intelligent values to the system and making it automated. Then the amount of computational power what we are going for, that means it is day by day increasing, the power is increasing. Before 10 years that is different, after 10 years, now in future in the next decade we can have in a different scenario. Now futuristic applications, as we are moving forward to the next decade and we are on the verge of ending 2020, so futuristic applications are must. That means we are expecting our mobile communication or wireless system to be everywhere and to have the best out of all. So that means application areas like healthcare, which is very important. We have already seen its impact in COVID-19 situation currently, which is running in entire world. So these application areas like advanced machine learning or AI techniques to enable these futuristic application areas will be very powerful. Then coming to the next generation wireless connectivity, it's obviously we have already seen within this decade that we have tried to shift our gears from 4G to 5G. Now In some cases, already the vision for 6G has already started. So various academia and industry, they have started thinking over 6G and what could 6G be. Then a brief introduction about artificial intelligence. So if we are saying it's about artificial intelligence, it is all a overall concept. That means it is enabling the computers to think like human or human intelligence. That means that doesn't mean that computers will be like human, but it will just our duty to teach the computer so that it can mimic the human behavior. Now, under artificial intelligence, how it works? It works due to the machine learning techniques. That means the machine learning algorithms or the statistics that we are using for by analyzing some of the problems. So, in those cases, statistical techniques are used to create some algorithms. Those algorithms are enabled to do the intelligent or to have the output in an intelligent manner. Then the deep learning is again the subset of machine learning. If you will go deep into the multi-layer neural network, that means if you will consider the brain's most important part is the neuron, which is doing all the computational work in a human body. So that means the deep learning is also consist of neurals or neurons, those who are doing all the computation work. And if the number of layers of neurons are increased, then that calls the deep neural networks. Then in those conditions, in some of the cases, it is considered as a black box because how it takes the decisions, that is unknown, and how it extracts the feature is unknown in some cases. But there are a lot of advantages of using deep neural networks in various fields of application other than wireless communication. So this is just a broad overview. Now, why or how the age of artificial intelligence has started? It is not new. It is just an old concept, but it has already started in 1950s. Now, at that time, the definition was different. Now, again, there was a boost of artificial intelligence techniques, neural networks techniques in the mid 90s. Then again, it has already been started from, more and more research has already started and applying cross-discipline applications of machine learning and artificial intelligence has already started. So the AI and ML fundamentally, that means they are both together can learn from the environment, automate the process, and optimize the complexity. So that means if we can say there are, it is the science of engineering making intelligent machines. Now again, the field of study that gives computer the ability to learn without explicit programming. So these are the definition already quoted in earlier 90s. But now we are trying to develop those programs, optimizing those programs. So that means our productivity is increased in socio. It has also socio-economic impact, which is increasing day by day. And those are trying those application of AI into the industries, application of AI into the agriculture. So every sector they are trying to capitalize the cost, reduce the human effort on those cases. Then so that means unrealistic expectation again.
और कन्वोल्यूशन थ्योरम क्या बोलता है कि जहाँ पे T रहता है वहाँ पे U और
excuse me, please switch off your mic. Okay, so thank you. So when we are thinking about AI and ML application in those conditions, there are questions every time. And the biggest myth is that the AI and ML will solve every problem so that it will capture the humanity and there will be no humans in the loop. But that is the biggest myth. That is not the complete truth, because AI/ML can automate some part of the process, but they are automated by, or they are operated by human at the center. So that is the biggest myth. Now, what is machine learning? In brief, not in a broader view, in brief, what is machine learning? So those are the algorithms, the intelligent algorithms. Those are intelligent because they learn from the historical data, improve the experience, and improve with the experience by iterating actions. So it is capable of improving its own programming. So that's why it is called intelligent as human, because as human we are trying to learn from our experiences. So that means we are improving our behavior by our own experience. So but in other cases, though it is applied for the computer, so they require data. So that means for machine learning programs, the data will speak, or the data will teach them to be intelligent and to take decisions. Now, a brief overview of the wireless communication generations. Now, generations means why we will call it a generation, because from one generation to 2G, 3G, then beyond 5G, the requirements are different and the application areas are different, and the service provided by the wireless system was different. Before 1G, there was mainly the communication, and the communication was through human or through animals. So those communications were also there. But when the wireless communication or technology comes, those are first try to send the text data, then voice, then it has already increased by providing the internet over service. Then they are designed to give the data internet protocols. Then the capacity, when it is growing day by day from early 90s to this point, within this 30 years, we have seen there are requirements are changing. Accordingly, the wireless communication is changing to provide those requirements to the users, because the number of users are increasing. So that's why their quality of experience and quality of service is also changing. That's why it is called the generation of the mobiles. So beyond 2020 or beyond 2030, there will be other generation, and we cannot speak that which generation will come within which year of time, but it will come. Then the applications of 5G. Now, 5G is different from other generation of mobile communication in certain way. That means the application areas of 5G are broad, because the quality of service provided by the 5G is huge. So, what are the services provided or application provided by 5G? If we can start from the healthcare system to our smart industries to autonomous vehicles or other what we can say intelligent transport systems, in all the cases we require certain requirements. That means the data which is generated from all these cases, they has to be transmitted, and it is day by day changing. That means we require higher data rate, we require certain other applications. So let for example in the factory automation case, so all the processes of the factory, though the production has been increased, though the requirement has been increased, so to increase the factory production and to increase the automation in a factory, to reduce the human effort, human error, to ensure security, safety inside one industry, so they have to be they have to adopt the wireless communications. But we cannot deny that in factory we can leave the total wired connection, but the wireless connectivity should in near future will overcome all those disadvantages. Then again for the smart grids, then smart healthcare is another big issue. Now smart healthcare or e-health system is definitely we can feel the requirement of e-health system now, because in this case remote surgery, in those conditions the robot is doing the surgery, and high quality AR and VR signals are required, so that it can within the millisecond time period or sub millisecond time period, so that those there will be no error in the operations. So it has already been tested in UK early in this 2000. So in those conditions, again IBM Watson and so many other companies, they are trying to incorporate machine learning and AI techniques into the healthcare system, so that it can be facilitated by the entire world and it can be explored and new services can be added. So after this application areas, we can say that 5G is having a huge application areas, but how 5G is going to tackle all those applications? What 5G is offering? 5G is offering basic service classes. That means 5G is consisting, or we can say 3GPP, third generation partnership project, which is under ITU, so International Telecom Unit. So in the inside that, they have standardized some of the services in the wireless communication. Like those services, they have categorized the quality of service, they have categorized the demand, and they have categorized the application areas. So in those conditions, they have defined the service classes. So it is very important to understand those service classes, what they are offering. So first is the enhanced mobile broadband services, or EMBB services. So in what is that? In the first phase of 5G deployment, so they have the deployment has already focused on the broadband transmission. Now, if we can see the virtual reality or augmented reality or video games, then 4K, 8K video streaming, all those conditions, those are required, very major requirements like high data rate. So data rate should be such that there will be no transmission error, and it require data rate, but it is not requiring very low latency of transmission. It is having the moderate latency of transmission, but it is a bandwidth hungry signal. That means it requires a lot of bandwidth for transmission of those high definition signals. So again, the use and applications are correlated here. Then comes the massive machine type communication. Massive machine type communication is, or for example, I can say it is the IoT communication, or we can say in an industrial industry floor plane, where there are various number of smart devices interconnected, connected to each other. So when they are connected to each other in those conditions, or for smart cities, we are conceptualizing smart city concept in India. So here also, what is smart city? So everything will be smart. So not so everything, but there are certain areas which can be smart. So smart means the sensing, monitoring through the sensors, and they transmit the data, and those data are transmitted and collected. Then again, those data transmission collection has to be processed. So they require a high connectivity and a large coverage. So next comes the most important is the ultra reliable low latency communication. So you can say it as a mission critical communication. So mission critical communication means, for example, in remote healthcare system or remote surgery, if the data transmission delays by some millisecond, there can be a chance of error in the operation. So that it is a it is a risk to the life. So that's why the data transmission in case of healthcare system will be the mission critical communication. For example, autonomous vehicle. If we will say that our vehicles, you must have, all of you must have heard about Tesla and autonomous vehicle. So in those conditions, what they are doing, that means without human interruption, the vehicle itself can navigate, can sense, can transfer or transmit from one place to other by carrying humans. So in those cases, a huge number of sensor devices, and again inside that there are transmissions of like security or collision detection. All those data has to be sensed and to be executed within some millisecond time period. That's why it requires high reliability of data transmission, and within sub millisecond transmission. That means the latency of user plane latency is within 1 millisecond, and the reliability is in the order of 10 to the power of 5. That is a basic requirement, and in some cases in factory automation it can go up to reliability of 10 to the power 9. That means there will be 10 to the power minus 9 packet error rate. So reliability will go up to 99.999% reliability is required. There will be no chance of error in those conditions. So these are the broad overview of the service classes of 5G, what they are offering, and application areas. Now comes why machine learning in wireless communication. It's very important to understand what are the capabilities of machine learning, because machine learning are capable of solving complex problems. Those are existing. That means why complexity is increasing day by day. In some cases, the problems are NP-hard problem. If you have knowledge about dynamic programming, in those conditions, you can say that some of the optimization problems are NP-hard. That means if we are trying to optimize, then in those conditions, it is not having any closed form solution. So in those conditions, if in other areas of cases, in other areas of cases, in those conditions, if the number of variables for the optimization problem increases beyond the expectation, that means if it is one or two constraint, then we can easily optimize it. If the variables are increased, then optimizing those minimization problems or maximization problems in those conditions are really difficult. In those conditions, computer can interrupt, they can have the data, they can keep track of the things. There are human errors in some data transmission. Like for example, another beautiful criteria of ML is the feature extraction and engineering. Those feature engineering can be waived. So ML's application in other areas other than wireless communication has shown the path that it can be implemented in some areas of wireless communication. Then the complexity. If we are looking at the complexity is providing a challenge, but it is also an opportunity. As for our researcher community, always we are trying to find out the opportunity inside the challenges, because that we are researching every time. So in these conditions, what wireless communication is having, what is the challenge and what are the opportunities? So challenge in previously, why not machine learning before 20 years in wireless communication, why it is now? The reason for that is before 10 years or 20 years, there were no concept of IoT, there were no concept of massive interconnection of smart devices. So in those conditions, previously the traffic and is due to the voice or data or small videos having low data rate. So and there are some limitation of computation also. Today we are having GPUs, CPUs of high power, then high power. We are having cloud services to store a huge amount of data. Then the computational power is also increasing day by day, and that's why um, we can try for some new things. Like previously the wireless network is very simple, it was homogeneous, the number of users were very less. So that's why there was no need to apply the machine learning or to explore these learning methods for automation of wireless. But now we are having this condition, like the explosion of data traffic in the wireless communication is changing. That means previous and it is beyond 2020, it is up to more than 50 billions are also predicted. So that's why such huge amount of data creates a lot of problem to be handled, to be managed and to optimize. And again, the massive data sets, ability to access those massive data set, we have computational powers in our home. That means using laptops, using GPUs, all those cases, and faster and cheaper processing we are getting. That's why we now heading towards the application of ML into that. Now, some of the basic learning models, which we can say in traditional programming condition, all those conditions, we are giving the input data, we are setting the rules, then we are getting the results accordingly. So those are the traditional programming. In those cases, sometimes setting the rule may not be enough to get the answer, but though the data was very less and the rules are simpler, in those conditions answers are easier. Now when the data is increasing day by day, then it is very difficult to handle. Now in coming to the machine learning part, there are three types of learning models. In general, we are going for it, that is supervised learning, unsupervised and reinforcement learning. Now most of you are aware with supervised learning. That means here data and the labeled data and input data and output data, the labeling is already done and the learning model learns from that, and from the data and output, it extracts the rules out of it. Then again, in the unsupervised learning answer, that means unsupervised means there will be no input and output accordingly. So sorry, there is data, so it extracts the rules from that pattern. So reinforcement learning is also the similar case. Again, in my subsequent slide, I will go in detail for the reinforcement learning. These are some of the learning models what we can see, and those learning models are having huge impact, or they can be easily implemented to other than wireless communication field. But now the importance of these learning models in various fields of wireless communication has already been started exploring. Now, there are, depending on the way information is provided to the customer, there can be other aspects of learning paradigm. That means some can be done by offline learning. That means we can learn our model or machine learning model, or we can say in simpler machine learning algorithm by using a predefined data set. For example, for computer vision, ImageNet, and ImageNet, MNIST, all those data sets, they can be used to pre-train your model. So there will be offline training of the model. Now online training when it is required, that means if there is a continuously dynamic changing pattern of the input, then in those conditions a predefined input cannot be helpful. So in those conditions the data is coming for the training in a sequential manner. That means it is changing in a sequential manner, so that it is going to the machine learning model, and the model or the algorithms learn from it, and in an iterative manner it tries to improve. Then active learning, that is the most important learning. So in active learning, what we are saying, that means in some cases online data is there. Let for example network traffic prediction. In those conditions the data is changing all the time, network behavior is changing all the time. In those cases our machine learning models have to be actively changing. That means the model has to actively learn from the changing data pattern at the base station. The next, these are the algorithm or the result. From the result, we can say that from the supervised learning and unsupervised learning. And again, another most important is the neural networks or deep neural networks, where I have already mentioned in my earlier slide that there are inputs and the neurons are there and the output is there, and the in between layer is the hidden layer, as you can see. Now in the hidden layer, it has the weights and biases. Depending on that, you have to it generates the output, and it can let for example, you must be familiar with the image recognition, cat or dog. So in those conditions they are using activation functions, so to get you the value, whether it is 1 or 0, or whether it is cat or non-cat, all those conditions. Now regression models are there, classification models are there, and clustering are there. So that means it is basically giving a number of data is given. That means the whole data set, you can say it is a training model, training data set, then testing. Then in those conditions the entire data is divided into two parts. That means it is trained with some of the data and to get the pattern out of it, and in classification it is trying to separate the data depending on its features what we have defined in this case. And similarly, depending on the features what we are trying to have, there is clustering, it is separating from one pattern to other. Then comes the reinforcement learning algorithm. Now, reinforcement learning is different from supervised and unsupervised learning. In those cases, in reinforcement learning, it learns from its reward hit and trial method. That means a continuous hit and trial method is done, and the agent takes the action depending on the environment. That means it examines the environment, and getting for each state it is getting a reward, and for each reward it is taking another action. So that means what is the total concept? That means reinforcement learning is trying to maximize the total reward in a long term and in short term also, but in a long term maximizing reward is the major aim of the reinforcement learning. That means maximizing the output that or optimal reaching the optimal behavior, and it reaches to the 99% of optimal behavior within some iteration, but it takes some time to reach to that level. That means the convergence time or converging of the reinforcement learning model is a bit or it you can say it's a complex challenge for this one. So for better understanding, let for example there is a bunny, and if it will move right, it will get 5 points. That means 5 points means it is a reward when it will have this carrot. So if it is moving left, it will get more reward. Then what this bunny will do, it will interact with the environment, how the decisions will be taken, how intelligent decisions will be taken. So when it will take the right turn, it will take the 5 point and the reward will be total 5. When it will take the left turn, then the reward after getting the carrot will be 10. But the next moment there will be sudden decrease of the reward. That means in total the maximization of reward in a longer turn is not there if it will take the left turn. So that means what is the optimal behavior in this condition? The optimal behavior is to take the right turn and take the reward of 5 points, so that in a long term it can increase the total reward. So that is the major aim of the reinforcement learning, or we can say there are various learning models are there, and it can be successfully applied to various wireless communication or 5G problems. Now, machine learning pipeline. That means how machine learning can be implemented to a certain problem. Machine learning cannot be implemented to each and every problem. So analyzing a problem is very important. So first is the problem definition, or to find out what is the basic problem on which we have to work on. Then data science problem formulation. That means the data what we are having. That means from the data how the valuable features can be extracted. So there are various data science terms like data mining and all those terms. So first the problem definition is very much important. Then comes the data collection. Now in case of wireless communication or in general network, this data collection is a very difficult task, because in my subsequent slide I will also tell about the challenges. So this is also a drawback for applying machine learning to the wireless system. But for the timing, for the pipeline case, I am explaining that after problem definition we have to work on the data we have, or how to extract the data, how to generate the data for our machine learning model is important. Then the data representation. That means transmission, again cleaning of the data, that or finding out the required or important features which can increase the overall output, or which can increase the overall success rate, or reduce the total error in those conditions. Data preparation. Then after doing all the feature engineering, we are now training the model. So for the training the model, we have to set the hyperparameter tuning. That means it is also one of the again challenges for machine learning. Now hyperparameter tuning, like for in neural network, number of layers, how many number of layers we have, how many neurons we have to take. So all those has to be handled in this stage. Then at the end there will be model deployment. After successful training we will test it and we will deploy the model. Then in the deployment, after testing, it will be deployed in the real-time scenario, and the results are monitored. Performance are measured with some performance metric is there. Then the model is deployed. So this is the basic pipeline of a machine learning. Before applying to any problem, these are the steps you have to follow. Then Coming to the wireless network, how these pipeline or how this can be applied to the wireless network. So again, initially you have to define a problem statement. According to the problem statement, as you can see, in wireless network we have our base stations, we have our user equipment or data centers. So by program or by optimizing some of the optimization problems, we can generate the data, and then or some of the standard data sets what are available for this one, we can take that, or some of the measurements, practical measurements, by implementing the experiments we can take the data. Then there is a process is the feature engineering. That means we will label the data, we will clean the data, we will take the important features out of it. So that means here we have to work to make our model better so that it can be implemented. Then data is splitted into two parts: training and testing. So in this case, training and testing, some of the data you can take 70%, 30%, and 20% training testing. That means development of the data set. So you can take this ratio for splitting of the data, and then the data is trained. So training means it is evaluating a function, so that the training data is giving you some of the outcome of that. Then after that, the model is tested using the testing data. So the testing data, when it is applied, then the model will estimate one output out of that. So that estimation error is again is fed to the training, so that to minimize the overall error in estimation and increase the total prediction accuracy in those conditions. Then the model is implemented, and we are getting the accurate prediction at the output. Y cap is the accurate or the predicted value, and y is the original output. Now the difference between these two, predicted value and the input value, is provided. Now, opportunities. What are the opportunities for 5G implementation? Now, there are various requirement of 5G implementation, like the broadband data require high data rate, then capacity is required for the massive connectivity, then density is connection density should be required, then mobility handovers. All those are various requirement. In those conditions, we can easily apply some of the basic machine learning models, evaluate its output, then see what is the outcome, and we can test it with some of the heuristic algorithm, applying heuristic algorithm. But when the complexity of the input increases, then in those conditions, it is better to analyze the problem first. Then we can say the flexibility is required. Then DNNs, in some cases, there are various, as I have already mentioned, various machine learning paradigms, learning models are there. They can facilitate, or they can go for some of the certain areas of the wireless communication, some of the certain focus areas of wireless communication. So in those data or wireless networking problem, we can say that, for example, regression of a supervised learning model, regression is very much essential in indoor localization. That means when a linear regression is frequently used for deriving empirical log distance model for radio propagation, or linear mathematical relationship development for the received signal strength indicator. So all those cases, linear regression models can be used, or for link quality estimation, or mobile traffic prediction. That means demand prediction, what should be the demand at a different condition and scenarios. And again, for classification models, they can be used for intelligent routing. Then they can be used for wireless signal classifications, various signal classifications. SDM models can be used. Then for connection density, in some cases, the clustering of the data, clustering learning models can be successfully utilized for sensor networks, how they are giving the data, what are the relationship between various clusters. Accordingly, it can predict what is the rule for the cases. So unsupervised learning can be used successfully there. Then radio signal identification is one of the other where clustering can be successfully implemented. So in those conditions, we can successfully implement some of the basic machine learning models to address the wireless challenges. Again, another machine learning models that we can use, that is for the latency and reliability ensuring. So for ensuring latency is the biggest challenge for enabling in this 5G. That means to transmit the data within stipulated time period is very much essential. So that's why intelligent management of the network or congestion control, or for example, we can say admission of the data or admission of how many users can be admitted, how many users are accommodated, depending on the available resources like frequency and time resources. So that has to be decided by some of the machine learning models, or here reinforcement learning models can be adopted. Deep reinforcement learnings can give good prediction values or good values for the better congestion control. So proactive user demands, that means in some cases, depending on the network challenge, available resources can be utilized and available resources can be distributed from the base stations depending on the prediction values. Then application of AI at various layers. That means at the physical layer, at the MAC layer, and the network layer. So data generated from the application layer. That means from the mobile, if we are talking, if we are transmitting video, so those are data that are generated. It is in the wireless media. Then those data, how to handle in the application layer what it is generating. So it is coming to the subsequent layers, where from the network layer, if we will go for the physical and MAC layer. So for the basic physical and MAC layer implementation, it was a really difficult and challenging task for application of machine learning. And in beyond 5G scenario, there are some of the areas like synchronization and positioning of the system. Physical layer systems are also there. That means time and frequency synchronization when cell synchronization process is required. So end-to-end autoencoders can be accommodated based on communication system. End-to-end deep neural network can be used. And in some classification based synchronizations are can be accommodated for the physical layer. And coming for the MAC layer protocol, MAC layer data transmission, in those cases efficient scheduling of the data, efficient resource allocation of the data is really important to reduce the overall latency of the signal. Now overall latency and reliability requires identifying the quality of service requirement of each data type. That means if it is a mission critical data, we have to give it the highest priority and transmit it. If it is broadband data, we have to schedule it on the more resources or more frequency and time resources. Then again here, there are some of the other challenges are there when multiple services are coexisting. In those cases, how to manage, how to intelligently manage the scheduling of the signal is also can be facilitated by machine learning models. Like for example, deep reinforcement learning models, they can be trained initially so that the convergence time will be low. Then they can optimally allocate the resources. Again, they can optimally schedule the signal accordingly, according to the priority. Then comes the network slicing. Why it is most important in network slicing? That means we are creating application areas for 5G. For example, factory automation. In those cases, there are various data generated. Or for example, autonomous vehicle. In autonomous vehicle, it is, if you will take the use case, in those cases. The safety and security data transmission or sudden braking, all those data transmission are very essential, that is critical. So those require high reliability. And again, those who are sitting there, they are browsing. There are broadband signals which are also coming. So a single vehicle is also continuously interacting with the roadside units to get the data, sensing the data. So and again weather conditions. So all kind of sensing and monitoring is going on, and the data continuous transmission and reception is going on. So in those cases, if there is a limited, and all of you know that our wireless resources are limited. So limited resources means that we have a stipulated bandwidth, we have stipulated frequency and time resources, and we have deadline constant data so that it can be transmitted. So in those conditions, we have to virtually, this is network slicing is a very good concept where we have to virtually separate the resources or reserve the resources for the different kind of transmissions. Here you can see the broadband slice, then massive IoT slice, then mission critical slice, and other slices or other virtual slicing of the resources is done to accommodate all these services at the same time. Then comes the learning models and the application, specific application areas of wireless communication. There are a rich content of research available online. So they are proposing, and the research is going day by day by applying various machine learning models to different areas for energy efficiency, cache management, then cloud storage at the edge, how to manage the cache so that the connectivity will be more, then dynamic frequency and bandwidth allocation. So there are various learning models, they are successfully applied to some of these areas, and again the areas are open for new model implementation and new challenges. So in those conditions we can also apply depending on the specific problem of the wireless communication cases. And again the beam forming, where the arriving angle of arrival, angle of departure, to estimate it, how we can find out automatic beam search. So all those things, how we can do it, or in those conditions this machine learning models, they can be very much useful. Deep neural network models can be useful successfully. Again, unsupervised learning. Here, unsupervised learning are applied to those cases where labeled data are not available. That means we don't have output for a specific input. So it learns from that data pattern, and it creates the rule, or it over or it outcomes is the rule by the analysis of the input data. So in those conditions like clustering methods and self-organizing map, those are the methods for the unsupervised learning, which can be easily applied to some of the areas of wireless communication like handover estimation or anomaly detection. If there is a intrusion, then in those cases, again I will cover those things. So autoencoders, all those things are can be applied unsupervised learning successfully. Then comes a reinforcement learning model. In this case, the continuous, as we know, the wireless environment is a constantly changing and dynamic environment. So the data which is generated is also constantly changing. So our model should have the potential to adapt to those kind of constantly changing environment. So there are various models like q learning models, then multi-embedded problems. So they what are these learning models? They are transforming a particular problem, and they are taking the value to put in these learning models so that in long term we can maximize the reward. For example, we some cases we are taking greedy approach for finding out the best possible reward, and in epsilon greedy approach we are defining some of the values so that it can have a trade-off between exploration and exploitation successfully. Then in some of in one of our work, we have successfully applied this reinforcement learning model for for having the better adaptive transmission and retransmission. For example, when we are sending a data from one transmitter to one receiver, so in that case, the transmitter is transmitting data. If the packet is lost in between, then in those cases, there will be retransmission of the signal. Now, retransmission of signal, when it is done, so let, for example, mission critical communication, that means your LLC communication. In those cases, when a data is transmit and again retransmission has to be done to ensure the reliability of the data packet receiver, then again we have to ensure the reliability under the constraint of latency. So in those cases, how to simultaneously satisfy the QoS condition? So in that, we have optimized, we have analyzed the problem, and a adaptive transmission and retransmission method we have adopted by using reinforcement learning, where at the start of a time period, transmission time period, it is called as TTI. At the start of the transmission time period, the sensing or the agent receives, or there is a state defined, a defined function of the state. There are various states, that means one transmission, two transmission, three transmission, under the constraint of the deadline constraint or the time period. So there is a state, and depending on the state, the agent takes the action whether to transmit whether to retransmit the data or drop the packet, depending on the satisfying both the condition. Then the reward is estimated by calculating what is the packet drop probability. So then, according to the reward, again the state action pair is updated, so that it is continuously monitoring and changing its value, and continuously improving its capacity. So in those conditions, in return, we have got very good result and proposed to a random selection or random transmission without those constant. We have got improved packet drop probability. That means our packet drop probability is reduced from the baseline, and the number of reserved resources are also reduced to certain extent. Now, the challenges, as I have already mentioned, there are various challenges when you will apply ML to 5G, and how to mitigate those challenges. So, for basic machine learning models, the major challenge is the data. That means how to find out the data. There is no standardized data. There is no standardized data generation method. And in some cases, synthetic data we have to generate to train our model. So there is a real scarcity of data for various deployment of 5G scenarios. So in those conditions, in experiments, we have to generate the data. So that's why there is no one size fit for all data representation. So in the that makes the data generation process a bit tricky and difficult for wireless communication. Then standardization problems or evaluation metric. How to evaluate your machine learning problem? There is a single problem. There are different models are there. What should be the standardized metric? Whether it be accuracy, whether it be precision, or is the convergence time. So all those metric in which we are evaluating the performance, that is different, and again same problem, different data and different output. So there will not be the match between all those things, so that is also a lacking in case of wireless communication. Then comes the data collection and transfer. It is again challenging just because of the billions of interconnection. So if the number of smart devices are transmitting at the peak network traffic condition, in those conditions, the data generated is huge. So transmission of those large volume of data and transfer, so that is also creating a challenge for application of ML model. Then no free lunch theorem. So that means it is a basic machine learning problem where you cannot say that this machine learning problem is better than any other machine learning models, or machine learning algorithm is better than any other algorithm in the world. That is not true. If we have applied some learning model, somebody else is trying to improve some of the parameters by taking better features to identify or to understand the problem and generate, that can be a better one. So there is no fit for all condition here. So that is also another disadvantage. Then again, the trade-off between accuracy and interpretability. Interpretability in general, that means we have to understand how the decision is taken by the machine learning models or the learning algorithms, how the decision is taken. If we will start from the classification models to going to the deep neural network condition. So in that condition, classification models are simpler to understand, that there is data, there is output that we can classify on depending on these features, like for example a cat or a dog, how it look like, or training over 1,000 of data, then we can predict this is a classification problem. But in some cases it is not possible. So in case of deep neural network or deep reinforcement, so in that condition, understanding why this decision is taken is very important, and that challenge is also very crucial. For example, you must have all of you must have heard about AlphaGo, developed by DeepMind. So when it is playing the Go at that time, it is taking some certain decisions which are beyond human capability to understand why this decision is taken. But when a human is thinking about, let's say for example, 1,000 moves, at that time this computer program can be capable of thinking 10 to the power 5 moves at a time, so that predicting a move out of that, so that it can increase the ultimate reward and increase and it can think to the some extent of the moves. So in those conditions, it is very much important how it is taking the decisions. Then hyperparameter selection, again selection, careful selection of parameter like learning rate, number of iterations are really important. Then performance metric, as I have already told, that defining the accuracy or convergence time. So all those are performance metrics are also required. So a standardized performance metric for a standardized problem is required. Then comes the privacy and security. Now, privacy and security is again the biggest challenge, which we can say. For example, CNN models can be faked by the deep fake by giving the fake faces, and it can be trained on the fake faces. So, privacy and security breach can happen at any stage. If you can start from end-to-end deployment, so from data transmission to reception, so privacy and security is the biggest threat in those cases. This, as I have already told, till now we have seen a little bit of challenge, but a huge number of challenges are really unexplored till now. Then ML in practical wireless, though it is a dynamic condition, so how it will adapt, it can be adopted by using active learning, by using some semi-supervised learning method where some of the data are available, some are not available label data. So learning from the label data and using on the unlabeled data, having better generalization can be used. Then again, transfer learning can reduce the complexity and reduce the computational time. So it is also useful. Then last but not the least, the federated learning. Federated learning model is a new learning model. It's not new, but it's a learning model where we can ensure or push the learning to the edge. That means it no more a centralized one, it is a decentralized learning model where the learning is all done at the cell edge at your mobile device, and the total computation or optimal values are transferred to the base station for taking the better action or better prediction. Now, as we can see, from a researcher point of view, we have to always update it with the recent trends, what is going on, how much search is going on in a particular field. We can always check with the Google Trends. So in recent years, we have seen there is a boost between deep learning and machine learning algorithms. Search and research is also going on. So that's why there is a boost in all those cases, and cross optimization or cross implementation at a different level of wireless communication and other fields are also going on. Then last is the 6G driving. After 5G, that will be 6G. New applications, new requirement, faster operation, and a lot more new quality of services can be visioned or visualized from here, because we have seen some of the success stories of ML and the implementation in the wireless. So there are various other areas of 6G or the 6G vision where machine learning can be applied successfully, and it can be an integral part of this. Then at last, the conclusion, that means I want to conclude here that there are enough promises provided by ML in other application areas, and when it is applied to wireless communication field, in some network field or physical layer or back layer solution providing QoS values, in those cases we have to be more intense with our experiment, and we have to train test every time with the different learning models, and understanding the problem is more important. Then we know that there is always a lot of room for improvement when you are analyzing a problem. Then our final goal should not be only understanding the machine learning, it should be combined with how machine learning can be applied to real time scenario. So the question, whether there will be machine learning, no, it should be when machine learning, and how it will automate the thing and integrate into the wireless communication. So thank you very much. Uh, Thank you very much for giving me time and patiently listening to me. So, any queries?
Thank you, Ms. Annapurna, for your wonderful presentation covering basic aspects of 5G and machine learning, including the supervised learning, unsupervised learning, and reinforced learning, and also explaining about the various models and algorithms which are used in various communication related problems, and beautifully explaining the challenges
Thank you, sir.
about various issues in using machine learning. So it is a wonderful overview presentation. There are
Thank
few
you,
questions from the participants.
sir. Sure.
Okay, any of you have already mentioned about the issues related to data sets,
Yes,
right?
sir.
So basically, the machine learning depends heavily on data sets and the accuracy of the data. Then only they
Yes,
will be able to predict the better models, right, for
yes, sir.
execution and maybe for optimization. So with the
Exactly, sir.
5G itself is evolving, and where do you get the data for optimizing the 5G related issues?
Exactly, sir. Standardized data is missing in this case. That's why some of the initiative by itself, IEEE is also has started. That means in IEEE ComSoc
They have a open
resources.
data. They have a data
Yeah,
archive,
exactly,
no
sir.
open data sets.
Yes,
Okay.
open data set, so that researchers can contribute there, so that it will be helpful for those who are trying to do research in this field, trying to understand what kind of data can be collected. So resources are there. Some of the best papers are in those particular field of research for wireless communication in IEEE ComSoc is also there. A link to the code of some of the standardized problem has been shared by some of the researchers, so it can be helpful for those who are doing or trying to do research in this field. So sir, I want to address some of the questions already mentioned, what you
Yeah.
have shared with me.
Okay.
That some of the questions like what are the prerequisite for this applying machine learning. So prerequisite, that means listening to machine learning models are there, wireless problem is there. So how to handle that before going into or jumping into machine learning? It is very much important to understand the problem, and you should have what I think basic understanding of the mathematics, like linear algebra and probability and statistics are required for understanding the machine learning. What is that? It is nothing simple mathematics, and where we can predict depending on the statistics is provided. And some questions are also very really interesting, sir, I want to address this especially, that when the RCB will win IPL, that was a question. So the thing is that when we are that is also a machine learning problem that we can apply also in those cases. Winning a game where we have to analyze the statistics, and we have to analyze the work of each and every player to predict a better machine learning model, so that prediction error will not be there, and someday it will predict that when RCB will win. So there are so many various questions, various different field where ML can be used successfully.
Mm. Is there any possibility of leveraging bots and botnets
Exactly.
in the optimization of 5G networks?
Sir, there are possibilities are there. For example, they have to be trained depending on the particular area. For example, if we are any bot, or in those cases network monitoring, in those conditions it is changing every time. So if there is a surgence of the data, so how it will behave? So to the extreme most condition, to the initial condition, we have to train our model depending on that. Then accordingly it can predict a better solution for network prediction.
Okay. In machine learning, what is the difference between bias and variance?
Yes, sir. Sir, there are these are basic, very fundamental questions that when we are learning machine learning, at that time we are defining the weights, we are defining the variance. So at that case, we have to optimize those values, bias and variance. We have to increase, in some cases, underfitting, overfitting of the machine learning models can be done. So to tackle between underfitting and overfitting of that, we have to deal with the bias and variances by changing or defining it initially at our learning process.
How to choose the best training model for massive MIMO?
Thank you, sir. Sir, this is interesting, and there are various research going on for the massive MIMO. For example, channel estimation in those cases, channel estimation or CSI estimation, and beamforming, where massive antennas are deployed. So in those conditions, some of the supervised learning method can be applied depending on the data, or for example, massive MIMO channel estimation case, we can have the estimation vector or estimation metrics, and we can train our model depending on that estimation metric, and it can predict a better estimation or SNR values by the collection of SNR values or received signal RSSI values indicators. We can train our model by carefully selecting the features.
Okay. Which learning model is best suited for security and privacy for IoT devices?
Exactly. Sir, IoT devices are, as we know, that they are vulnerable to these security threats. So, in those conditions, securing the data at the level in the where the machine learning models are not public, that means when they are adopting the data, for example, as I have mentioned in the federated learning mode, in those cases, ensuring the security at the edge devices is important. And then with and at the base station or at the central position it is also required. So in those learning models there are various research are going on by applying active learning models to detect the anomaly pattern, or what are the anomaly detection methods are also there. So there are various different detection process and clustering methods are also there, where we can also apply in the machine learning or this security to address the security threats.
Okay. When to apply the machine learning to reduce the power consumption in the base station of the cellular communication?
Yes, sir. Good question. The base station power consumption depends on the active and inactive pattern of your UE and base station transmission. That means by proactively predicting the active and inactive pattern of the UE transmission, so the data can be transmitted or not. So, by prediction of those states, we can reduce the energy consumption or transmission of data.
Okay, can you explain message passing algorithm for massive MIMO?
Sir, actually, I have already heard about that, but I'm not into that research mainly. I am into the MAC layer and other research. So there are rich content is there where a lot of research is going on for the massive MIMO case. We can refer to that.
Okay. In the absence of metrics and varied issues relating to accuracy, how to zero down on a particular model for optimizing 5G application? So because you said that there are challenges both in the case of metrics, and also the accuracy itself is not ascertained.
Exactly.
So then is it going to be a trial and error, or
Exactly. Sir, trial and error here, accuracy depends on, if you can say, the false alarm. That means what is the true parameters, or how our predicted value is, whether it is equal to the real value or not. So that parameter in those false alarm cases that we can reduce, if the machine learning models can reduce those false alarm cases, that means if it is a true condition and it is predicting a false condition, so if it is not giving the entire harm, then in that case we can minimize those false cases and increase the accuracy overall.
this 5G, I mean, basically these ML applications, they require heavy computing power, right?
Yes, sir.
And see, the 5G itself is working for the low latency. So how do they go together? High power and low latency.
Exactly. Sir, low latency is the basic requirement of 5G because there are various applications are there. Now, computation of some machine learning models, for example, when the decision making initially, for example, if I am telling the reinforcement learning model, initially convergence time is the biggest challenge for these models to ensure. So any data transmitted with, whether it is successfully transmitted, that decision of transmitting the data again or not, so that decision should come within millisecond time or very less time period. So before that, how to increase the convergence time? So optimally defining the policies and training the model on the defined policy can increase the efficiency of the model itself initially. Then the decision time will be reduced. By that, latency can be ensured. I am telling just one use case. There can be other use cases.
So, which means that most of the applications have to run on edge computers, right? Not on the cloud.
That is to some limited, there is also some limitations are also there, sir. That means computation at the edge devices are also difficult because they have the low computation power, like your mobile phone or laptop, they have less computation power. But we can cache, we can do it by actively managing the cache and the fog networks for better accessing of that. Though the 5G is divided into, if I can say, it's into broadly two type, that is a random access network or the core network. So in those cases, reducing latency depends on queuing of the data at the base station, then minimizing the transmission error, minimizing the backhaul transmission time. So it is a combination of different time period. So minimizing any of the factor can reduce the overall latency. So that's why user plane and control plane latency has to be tackled at the same time.
Okay. Are there any codes available for this machine learning and 5G? Any repositories are there?
Yes, sir. There are there is a rich content of courses available online. That depends on the particular interest area. Basic understanding of machine learning, very good books are there. There are books for deep learning by Ian Goodfellow. There are books by Andrew Sutton for the reinforcement learning. Some basic idea you can get from various books also. Courses are available. Our NPTEL courses are available. Very good courses are there from professors from IITs and NITs. So they can also go for those courses for better understanding and better having better knowledge about the area.
Okay, okay. No, this is basically along with the courses, are there any code that is a machine learning code,
There are
programming
various,
code?
yes, sir. There are various programming codes are available, like repositories like GitHub, Stack Overflow. Those are also there. They can go and search for the codes. But again, blindly applying those codes to your problem is not recommended, because understanding someone's problem and applying someone's code may not work. So that's why understanding machine learning first, then understanding the code what has been given, then applying to the particular area by doing the needful changes to the code. That can be done.
Can you suggest some research topics for the undergraduate and postgraduate students in this area?
Sir, research topic for undergraduate, currently undergraduate and postgraduate students are doing a lot in this area. Like for example, in our college also, they are working on autonomous vehicle, they are working on underwater vehicle, autonomous vehicles. So there are also work on different diversify areas apart from wireless. In wireless also, there are areas like basic channel estimation, MIMO technique, beamforming. So there are also some of the areas where they can work.
Okay. Are there any standards to introduce machine learning into 5G by ITU or some standard organization? Have they come out with any standards?
Sir, actually, I have mentioned in my slide that till now standardization was a big problem for applying machine learning, because no standard data set, no standard model is there. It is just only, like for example, we have a ImageNet or MNIST data set, so that every computer vision application engineer, they can use those data set. But that is lacking in wireless communication, though it is gaining attention in recent few years. So I think ITU bodies will come up with the solution really fast.
I think they have some draft announcement has been made for the
Yes, sir.
Y.3172 or something like that, right?
Again, release 16, release 15 they have done, but not. I was not aware of that.
Still a draft, possibly the draft announcement.
Okay.
And is there any way that GPT-3 or the model can be used for communication problems?
Yeah, transformers can be used, and they can be used where we require memory. That means understanding or making patterns out of the historical data. They can be implemented. So LSTMs, instead of LSTMs, they can be used successfully.
Okay, what
And
is your specific research problem? You are doing
Uh,
your. Can you
Sir,
explain about your research problem?
sure. Research problem currently, that means I'm looking into the ultra reliable low latency communication, as I have already mentioned in my slide. So that means it is a problem for a specific use case where I can say what is the total requirement of data reliability transmission reliability, and how faster it can transmit, what is the basic standardized requirement, how it can be minimized by analyzing all the delay elements which are contributing, like for example queuing delay, for retransmission delay. So by analyzing all those things I am trying to do, and again I am working on some of the service classes and its implementation, coexistence, and other areas are also I am working. So currently I'm looking for some of the specific use case areas so that I can test my models and deploy it. Again, I'm also facing some of the challenges related to the data set, so I'm working on that.
Okay. Thank you very much, Ms. Annapurna, for your wonderful presentation. Now I'd like to request Dr. Saktivel to propose the formal vote of thanks. Dr. Saktivel.
Thank you,
Good
Mohan
evening
sir.
Good evening, sir. Good evening to all the participants of this webinar. On behalf of the Computer Society of India Chennai chapter, ACM Chennai Professional Chapter, and IEEE Computer Society Madras Chapter, we would like to thank today's resource person, Ms. Annapurna Pradhan, for her excellent lecture on machine learning for 5G and beyond, opportunities and challenges. Both the areas, machine learning and 5G, are evolving areas, and she has given a lot of information, and she has answered many questions in an excellent way. So, on behalf of all the societies, we would like to thank her. Thank you, madam.
Thank you
I
for
would
your
thank
sir.
Mr. H.
I
Chairman,
want to
ACM Chennai chapter, Mr. P.V. Subramanian, Chairman, C. Chennai Chair, and Dr. Ahila, Managing MD member, Chennai Chair, their excellent and dedicated effort in organizing this dinner. And last, I'd like to thank all the participants who have participated through Google Meeting link and YouTube and participated in this. Thank you, one and all. Thank you very much. Thank you, sir.
thank you everyone. Thank you for having me.
Thank you. Once again, my thanks to Ms. Annapurna for the presentation. And before we formally close our today's session, I have a few announcements regarding our future program. On 12th of November, we have a program on innovations in the new normal. And on 16th, we have a program on IPR, patents, and how to go about applying patents. And 21st, we have a program on data analytics. So we have already sent the invitations to our members and other group. Please register and then start attending them and get benefited. So thank you, Ms. Annapurna.
Thank you, sir. Thank you, everyone.
We
Thank
look
you.
forward to your continued association with us.
Definitely, sir.
Thank you. Thank
Good
you.
night.
Good night.
Good night.